The quest for extraterrestrial life has inspired countless science fiction stories and driven ambitious NASA missions. One of the most captivating locations in this search is Europa, one of Jupiter's moons, which many scientists believe could harbor vital information about the possibility of life beyond Earth. Bill Nye, the renowned science communicator, is among those advocating for further exploration of Europa, as it might hold the key to unlocking the mysteries of life in space. The curiosity about extraterrestrial life was further sparked by NASA's Voyager 1 spacecraft, which was launched in 1977. Voyager 1's landmark discoveries extended our understanding of space beyond our own solar system. Among its many findings was the detection of ionized gas particles interacting just outside the heliosphere, the protective bubble created by the solar wind. This provided significant insights into what conditions might be like beyond the solar system. Could these readings be signs of extraterrestrial life? This question has fascinated scientists and space enthusiasts alike. Bill Nye, a passionate advocate for space exploration, has repeatedly highlighted the importance of investigating these celestial bodies, and the data sent back by Voyager 1 has fueled this interest. The discovery has the potential to answer the age-old question: are we alone in the universe? To understand why this discovery is so crucial, we must revisit the early days of space exploration. In the 1960s and 1970s, NASA had recently achieved the monumental feat of landing humans on the Moon through the Apollo missions. This success generated global excitement and fueled further ambitions in space exploration. Soon after, NASA set its sights on the outer planets of the solar system, but sending humans on such missions was not feasible due to the vast distances and the limitations of 1970s technology. It was clear that unmanned spacecraft would be key to exploring these distant worlds. During this time, the Cold War rivalry between the United States and the Soviet Union was at its peak, and both countries competed fiercely in the field of space exploration. The Soviets had taken the lead by launching the first artificial satellite, Sputnik, in 1957, and sending the first human, Yuri Gagarin, into space in 1961. However, the U.S. pulled ahead with the Apollo 11 mission in 1969, when astronauts Neil Armstrong and Buzz Aldrin became the first humans to walk on the Moon. This marked a turning point in the space race, but the U.S. understood it could not rest on its laurels. The competition with the Soviet Union continued to drive NASA's ambitions, leading to plans for missions to explore the outer planets. NASA's first steps toward these distant worlds involved the Pioneer spacecraft, which were launched in the early 1970s. Pioneer 10, launched in 1972, was the first spacecraft to fly by Jupiter and return pictures, while Pioneer 11 followed in 1973, continuing the exploration of the outer planets. However, to study the outer planets more effectively, NASA needed a more advanced spacecraft capable of collecting detailed data from Jupiter, Saturn, Uranus, and Neptune. This led to the creation of the Voyager program. The Voyager mission was groundbreaking, designed to take advantage of a rare planetary alignment known as the Grand Tour, which occurs once every 156 years. This alignment allowed the spacecraft to slingshot from one planet to the next using gravitational forces, making it possible to explore all of the outer planets in one mission, saving both time and resources. 2 Voyager spacecraft were built: Voyager 1, which was designed to visit Jupiter and Saturn, and Voyager 2, which would take a longer trajectory to reach Uranus and Neptune. Voyager 1 was launched on September 5, 1977, and began sending back incredible images and data, revolutionizing our understanding of the outer solar system. In January 1979, it started transmitting detailed photographs of Jupiter, including the famous Great Red Spot, a massive storm that has been raging for centuries. Voyager 1's mission did not end with Jupiter. After completing its flyby of the giant planet, it continued on to Saturn, where it provided even more significant discoveries. One of Voyager 1's most important contributions was its detection of ionized gas particles beyond the solar system. This data has had a profound impact on how we view the universe and the potential for life beyond Earth. As the Voyager spacecraft continued to send data from the far reaches of space, the search for extraterrestrial life remains as crucial as ever. Bill Nye and other scientists believe that exploring places like Europa, with its subsurface ocean, could yield the next great breakthrough in this quest. What we learn from these missions could forever change our understanding of life in the universe. One of Voyager 1's remarkable achievements was its ability to capture images and compile them into a color stop-motion video. This technique allowed the spacecraft to create a film showing 10 rotations of Jupiter, and by February 10, 1979, Voyager 1 had entered Jupiter's moon system. It sent back footage of the planet's moons, including Io, Europa, Ganymede, and Callisto. These images provided invaluable insights into these moons, some of which bear little resemblance to our own moon. The Galilean moons, discovered by Galileo Galilei in the 17th century, have become key objects of interest for space exploration. One of the smaller moons observed by Voyager 1 was Amalthea, a reddish and irregularly shaped satellite with a peculiar surface composition. Images revealed that it was made of ice and silicate materials, with the red color due to the presence of organic material. Its highly irregular surface indicated that it had experienced little internal activity compared to other moons. Io, the most geologically active moon in the solar system, displayed numerous active volcanoes and lava flows. These volcanic activities were driven by tidal heating, caused by Jupiter's immense gravitational pull. This made Io appear more like a volcanic hellscape than a moon. Europa, however, was particularly intriguing due to its smooth, icy surface, which covers what scientists believe is a vast subsurface ocean. This moon, along with others in the Galilean system, remains a key target in the search for extraterrestrial life, as its hidden ocean may provide the necessary conditions for life to exist. As space exploration continues, the Voyager missions stand as one of the most significant milestones in our understanding of the cosmos. The data sent back by these spacecraft continues to inspire scientific inquiry and fuels the ongoing search for life beyond Earth. With advocates like Bill Nye pushing for deeper exploration, Europa and other moons of Jupiter remain central to our hopes of answering one of humanity's greatest questions. Are we alone in the universe? Many scientists believe that life could potentially thrive beneath the icy surface of one of Jupiter's moons, making it an exciting candidate for extraterrestrial life. Recent observations have identified several cracks on this moon's surface, hinting at past collisions with asteroids and smaller comets. Among the findings was the discovery of Ganem, the largest moon in the solar system. It was so massive that it dwarfs the planet Mercury and possesses its own magnetic field. Images of its surface revealed a rocky and icy landscape. Ganem's complex geological history continues to intrigue experts, and it is believed to have a liquid core deep within, responsible for its strong magnetic field. Another large moon, Callisto, the second largest of Jupiter's moons, was also studied. Its heavily cratered surface indicated a long history of impacts with space rocks and a lack of geological activity. Similar to Europa, Callisto is believed to have a subsurface ocean, raising the possibility of alien life. The spacecraft also discovered two new moons, named Phoebe and Matisse, both of which are small, irregularly shaped, and orbit much closer to the planet than the other moons. Interestingly, Jupiter and its moons were named after figures from ancient Greco-Roman mythology, reflecting their connection to the king of the gods. After completing its flyby of Jupiter, the spacecraft adjusted its course to avoid drifting endlessly through the solar system. It then set a course towards Saturn, which it would reach about 6 months later. In October, another course correction was made to prevent a potential collision with Titan, one of Saturn's moons. The spacecraft's encounter with Saturn was just as impressive as the one with Jupiter. It discovered 5 new moons, a ring system composed of thousands of particles, and mysterious cloud-like structures called spokes. One of the newly observed rings remained hidden until close proximity, while satellites were found to play a key role in maintaining Saturn's iconic rings. Among Saturn's moons, Titan stood out as one of the most intriguing. When the spacecraft approached it on November 12, it was less than 3,000 miles away. Titan's thick atmosphere, composed primarily of nitrogen and having surface pressure similar to Earth's, completely obscured its surface. However, the conditions on Titan indicated it might be the only body in the solar system, apart from Earth, where liquid could exist on the surface. Chemical reactions essential for life seemed to be present, with strong evidence of hydrocarbons, further raising hopes for the possibility of life. By November 12, 1989, the spacecraft had completed all of its planned planetary flybys. Both spacecraft, though past their original missions, were still operational and transitioned into the Explorer interstellar mission, a mission aimed at exploring the region beyond the outer planets and possibly even the interstellar medium. This new mission officially began on January 1, 1990, with a goal of studying the magnetic and solar fields, as well as the interstellar environment. By February 17, 1998, Explorer 1 became the most distant human-made object, surpassing Pioneer 10, traveling over 70 astronomical units. Even 45 years after its launch, Explorer 1 was still functioning, transmitting data back to NASA's Deep Space Network. It was a surprising achievement that its instruments, including a powerful telescope and magnetometer, continued to work well after so many decades in space. In 2012, Explorer 1 entered interstellar space, marking humanity's first journey into this unknown realm. This historic achievement provided scientists with a unique opportunity to study conditions beyond the heliosphere, the protective bubble surrounding our solar system. Data from Explorer 1 helped improve our understanding of cosmic rays, magnetic fields, and plasma interactions in interstellar space. Explorer 2, which entered interstellar space in 2018, continued to send similar data, offering deeper insights into the outer limits of the solar system. Both spacecraft carried records containing sounds and images intended to represent Earth's life and culture, serving as a message to any potential extraterrestrial civilizations. As the explorers ventured further, they also contributed to the field of space science by studying phenomena like the interstellar medium and solar wind interactions with the vast environment. These discoveries have significantly advanced our understanding of the heliosphere and the interstellar magnetic field. Looking ahead, the data from these missions is expected to play a crucial role in future interstellar missions. As technology advances, scientists and engineers are using the lessons from the Explorer missions to develop new spacecraft capable of traveling even farther into space, possibly to explore nearby star systems or probe the boundaries of the Milky Way galaxy. The legacy of the Explorer missions lies not only in the groundbreaking discoveries they made, but also in their role as humanity's pioneers in the deeper exploration of the cosmos.